9.5 covers population proportions. Using a proportion, we are going to look at lower tail tests, which is represented here, upper tail tests, or two-tailed tests. Now, the only difference between conducting hypothesis testing for proportions and for sample means is that we have to use the standard error of the mean. So first thing I want you to do is to pause this video, go to chapter 9 in Blackboard under the folder where you can locate the data sets for chapter 9, and I want you to pull up the data set for women golf. Once you have pulled up this data file, I want you to compute the proportion of female golfers. This is the file that we are going to use, to go through this, the examples for 9.5. In the scenario where you're using the data set for women golf, this is an example of Pine Creek Golf Course. Over the previous year, 20% of the players at Pine Creek were women. So they wanted to increase the number of women, or the proportion of women golfers. And they implemented a special promotion to attract women golfers. So 1 month after the promotion was implemented, the course manager wanted to determine if the proportion of women players at Pine Creek had increased. So, considering this example, we are going to look at which hypothesis we're going to use. Now remember that the null hypothesis is status quo. It's what we consider to be true unless we have overwhelming evidence to lead us to the indication that the promotion had an impact, that it actually increased the proportion. So what we're testing here, remember this area right here is going to be our status quo. That's our null hypothesis. Now when we conduct our testing, if our values lead us to this area right here, then we can reject the null hypothesis. This is our alternative hypothesis. So the formulas that we're going to see in testing hypotheses with proportions are the sample proportion, or the standard error of the sample proportion. So and we're going to compute this value because we need it to compute our test statistic, our z-score. So the formula again for standard error of the proportion, we have our hypothesized value here, multiplied by 1 minus our hypothesized value, divided by the number in our sample, and then we take the square root of that value. The other formula that we're going to use is the test statistic, which is our z-score. And to get our z-score, we have to take our sample proportion minus our hypothesized value, or the value that we're testing against. And then we take this piece right down here. Once we have that value, we divide that top number by the standard error of our proportion. So let's walk through this scenario. All right, the first thing that we need to do, step 1, is to determine our hypotheses for this test. So step 1 here, to determine our hypotheses, we're going to look at the null hypothesis I say hypotheses because it is plural. We have our null hypothesis and our alternate hypothesis here. We're going to set the null hypothesis as being less than or equal to, because remember, the null hypothesis is this area right here. It's our status quo. Now, in this scenario, as I had indicated before from this example that we're going to use, the values that they had for the proportion was 20%. So they had 20% of their golfers were female golfers. So we are testing against 0.20. We have to assume that the promotion did not increase the number of female golfers unless we have overwhelming evidence that indicates that we can reject the null hypothesis. So this area up in here, right here, is the null hypothesis, and it's represented by less than. So it's this area under the curve. The alternative hypothesis is going to be written as greater than 0.20. So that's step one. Step two, we have to specify our level of significance. So we're going to look at this with an alpha level of 0.05, so 95% confidence. So alpha is going to be 0.05. And then step three is to compute the value of our test statistic. So to compute the value of our test statistic, first, we need to compute the standard error of our proportion. Second, we need to compute our z. Now, the data file that you pulled up that had 400 data points or elements in it, that was the sample. So once you've you should have already computed that before this point in the video. So looking at that, you should have come up with a sample proportion of 0.25. All right, let's walk all the way through this one. We're going to go ahead and complete step number 3, computing the test statistic, first by computing the standard error of the proportion. So step 3 here. Again, we're going to take our proportion, our hypothesized value, multiply that by 1 minus our hypothesized value over the number in our sample, which in this case 400. So, and then we take the square root of that. So 0.20 times 0.8, because it's 1 minus 0.20, over 400, and we get the value here of 0.02 for the standard error of our proportion. All right, so let's go back here. We've got our alpha level set at 0.05. The number in our sample size is 400. Our proportion, the value that we're testing against, is 0.20. We have, the next thing that we're going to do is calculate our z-score. So we have the value here for standard error of our proportion is 2, and our sample proportion, you should have come up with, in that data file, you should have ended up with 100 females over 400 total golfers, and that gives you a 0.25. So our sample proportion is 0.25. To get that super quickly, you can do your count functions in Excel. In this case, it would have been using your equals count if function. And then you highlight your array, and this was A2 through A401. Can't read that very clearly because my marker's too thick. And then you have to make sure that you click on a cell that contains the word female in it. So your array, comma, I'm going to cross that out. So that's A2 through A401, comma, female. And that should have given you 100. And you have a total of 400 in your sample size. All right, so we've computed the standard error of our proportion. Now let's compute our z-value. And our z, again, is our sample proportion minus our hypothesized value, 0.2 in this case, over the standard error of our proportion. So we get 0.25 minus 0.20, and we take that over 0.02, which gives us a 0.05 over 0.02, and our test statistic is 2.5. So next thing that we are going to do is look at the probability, or we're going to compute the probability using our test statistic. All right, so because we're looking at, again, an upper tail test, because the manager wants to know if the promotion increased the proportion of female golfers. So because it's an upper tail test, the p-value is the probability that z is going to be greater than or equal to z of 2.5. All right, so to get the value here, we're going to get equals norm.dist, norm.s.dist, and then we're going to put our z-score in here, and then we're going to put true. And this is going to give us the probability of this end of our distribution. So again, it's going to return the lower tail. That formula is always going to return the lower tail. So if we want the upper tail, we have to do 1 minus dist. Okay, so 1 minus dist, which is going to give us this area up here. That's what we're going to be comparing against our hypothesized value. So equals 1 minus norm.s.dist, and then put our 2.5 and true in there, okay, is going to give us 0.0062. Now, what significance is this? This is what we have to look at and that we're going to compute and test. All right, quickly, I want to remind you here of what our hypothesis is looking at. So if our alternate hypothesis we reject the null hypothesis. In this case, we have 0.0062 is less than 0.05, so we reject the null hypothesis. It appears that it did increase the proportion of female golfers. In the next video for this section for 9.5, we're going to walk through that Excel data file, and we're going to walk through the formulas that we will use to conduct these types of tests for population proportions.